Welcome! These notes cover a deck of cards done with inheritance and polymorphism. The prerequisites for these notes is that you have completed reading the chapter material on inheritance and polymorphism and have reviewed class hierarchies. We're going to take a look at a simple class hierarchy for deck. You've already coded your Pinochle deck. We'll see how the code lays out for a superclass deck and deriving from it ordinary deck of 52 cards and a Pinochle deck with 48 cards. The presentation will walk you through a simple problem that demonstrates inheritance, polymorphism, the use of abstract class and abstract method. Here is the UML for the deck. Abstract class deck. As members of the deck, we see the array of cards named deck and our integer top card that helps us keep track of which card is next to be dealt from the deck. There's a set deck method that's abstract. This will be overridden in the ordinary deck and the Pinochle deck, as when we construct those decks of cards, we certainly have to do them differently for a card deck of 52 unique cards versus 48 cards that are not unique. The two-string method, the deal a card, the shuffle, and we see a string type called getType. The getType will be a polymorphic method that allows us to have each deck report what type of deck it is. Notice that shuffle, deal a card, and the two-string are all handled in the abstract class deck. Why? Well, those operations are done the same regardless of the type of deck. We'll want to shuffle all the cards, be able to deal one card from the top, and show the entire deck of cards. So since these are common, we push them to the top of the hierarchy in the abstract class deck. Now recall from your readings and previous notes, what does it mean to be abstract for a class? Well, it means that we're not going to have any deck objects instantiated. We will only be able to instantiate ordinary deck objects or Pinochle deck objects. There will be no deck objects. However, we can use the deck reference to refer to ordinary deck or a Pinochle deck object. Let's take a look at the code. Abstract superclass deck has a final int num cards. That will be 52 for our standard deck of cards, but for our Pinochle deck, the num cards will be 48. We see protected members, deck of cards, and top card. Remember, the top card will allow us to keep track of the next card to be dealt from the deck. The constructor for the deck requires that we provide a size. This is important because num cards will be 52 for an ordinary deck and 48 for our Pinochle deck. We set the num cards to the size, and then we instantiate the deck to consist of that number of cards. We set the top card to 0. There's an abstract protected method called setDeck. The setDeck method will be responsible for constructing the deck of cards. Because we don't know what kind of deck this is, and this is an abstract method, we are providing no definition for this method. Notice it looks like a C++ prototype with the keyword abstract in front of it. So we know then that this method will be and must be overridden in the child classes. So subclass ordinary deck, subclass Pinochle deck will provide their own set deck. The two-string method displays all of the cards of the deck. Notice it's based on num cards. So both the ordinary deck and the Pinochle deck will be able to use this method and display all the cards. The deal a card deals the top card from the deck and returns it. Notice the return type is card. If top card is greater than or equal to num cards, then we reshuffle the deck, top card gets set back to 0, and then we deal the top card from the deck. The shuffle method, again, mixes all the cards in the deck, going through the deck 3 times and exchanging each card with a randomly chosen card from the deck. By using num cards, this works whether we have 52 cards in the deck or 48 cards in the deck. Or if you came up with another type of deck that you wanted to create, maybe only had 18 cards in the deck. Finally, we see abstract string get type. This will return the type of deck, and both of the derived classes or subclasses, Pinochle deck and ordinary deck, have overridden this method to report the type of deck they are. Let's look at the ordinary deck. Now the ordinary deck, and notice the ordinary deck extends the deck. The constructor passes the number of cards in our ordinary deck, which is 52, up to super class deck. The super class deck constructor will use that number to set num cards. The next thing we do is call the set deck method. This used to be in the deck constructor, but since we need to do this differently for different types of decks, we've put it into the set deck method and made set deck an abstract method that each of the subclasses overrides. It will go through each card in the deck from 0 through 51 and assign it a proper suit and value. Then it instantiates that particular card of the deck. The get type returns the fact as a string that this is an ordinary deck. So these are the only methods we need now in the ordinary deck. Here's our Pinochle deck, extends the deck. The Pinochle deck will have 48 cards. We pass this information up to the super constructor, so when the deck constructs, it will construct with num cards set to 48. There's our set deck call, and the set deck for the Pinochle deck will loop 24 times, set the value between 9 and 14, and then set the suit of cards for either diamonds, hearts, spades, or clubs. Notice below, deck sub I will set the card, and then we have deck sub I plus num cards divided by 2. This loop, instead of going through the deck of 48 cards, because there are 24 unique cards, just loops 24 times and sets 2 cards to the same suit and value. The get type reports this to be a Pinochle deck. Let's take a look at test card for a moment. This was our original driver file. We see that we declare an ordinary deck called myODeck, and then we use the toString to display it. Then we create a Pinochle deck called myPinDeck that will also call the toString and display it. Now, if you recall, we did not write any toStrings in the ordinary deck or the Pinochle deck, so it will use the superclass deck toString method. Then we create an array of 3 deck references. Now recall, we can't create a deck object because it's an abstract class. However, we can use these references to refer to the subclass objects, my ordinary deck and my Pinochle deck. And that third reference will be assigned to a new Pinochle deck. Then we use the for each loop to shuffle and display the type and the deck. There's the polymorphism going on. When we call d.getType, this will invoke the get type for either Pinochle deck or ordinary deck, depending on the deck type that the reference refers to. Let's run this with the debugger and examine what happens and in what order and when. So we're right at the start of public static void main. The green arrow is resting on that first line of code, which means we have not yet completed that line of code. Let's step into it. This will be invoking the ordinary deck constructor. Here we are at the ordinary deck constructor. The first line of code for the ordinary deck is to invoke the super constructor. Let's step into it. In order to construct the ordinary deck, we need to first construct its parent, super deck. We are passing in the size, and we see that we'll be setting the size of num cards equal to 52, then instantiating an array of 52 cards. Now this is just setting up those references. We haven't built the cards yet. We'll see that done later. And then top card gets set to 0. Stepping again, this should take us back to our ordinary deck. And sure enough, here we are back at the ordinary deck. The next thing that we're going to do is set up that deck of cards. For the ordinary deck, we will have to build 52 unique cards. We call the set deck. Initially, we set the I val to 0. The suit initially is set to clubs. And then we loop through all 52 cards and set the values from 2 through 14. 2, 3, 4, 5, 6, 7, 8, 9, 10 will refer to the values of our 2 through 10 cards. 11 will be the jack, 12 will be the queen, 13 for the king, and 14 for the ace. Then we switch to assign the suit of the card. The first 13 cards will be the 2 through ace of diamonds. We instantiate the 2 of diamonds. We are now in the card constructor. So for this individual card, we see the construction happening. We're going to be setting it to the 2 of diamonds. Okay, we're finished constructing that card. We go back to the top of the loop, and now I is 1. And don't despair, I will not walk you through all 52 cards. But clearly, the next card, let's just look at the next card. With I equal to 1, the I val will be set to 3. And when we divide 1 by 13 in an integer way, we still will have a result of 0. So this time we're constructing the 3 of diamonds. We won't invoke this constructor this time, but we see that we will be building the 3 of diamonds. And I encourage you to use the debugger to walk through your code to see what happens and when, especially in terms of construction. I'm going to step over constructing that card, and here again, we're at the top of the loop. We'll be setting the next card to the 4 of diamonds. Right, just to show that, there's I val set to 4. We divide 2 by 13. We are still going to have a value of 0 for the suit, which will then be set to diamonds. Okay, so here we see it, the 4 of diamonds. So when we're finished, we'll have constructed this entire deck. And I want to step out of this. We finished constructing the ordinary deck after building all 52 cards, and we're back to the main. The next line of code, we are printing the ordinary deck. Now notice the use of the object, myODeck. That will invoke the toString. Recall though that we did not write a toString for the ordinary deck, so that will use the toString provided by the deck. All right, let's step into constructing our Pinochle deck. Here we are at the Pinochle deck constructor. It will invoke the deck constructor. and send it 48 to indicate that the Pinochle deck will have 48 cards for a num card size. There we see it. Construct the deck array of 48 cards. Again, this just is setting up the references. This doesn't build the actual cards. We will be doing that in the set deck. Set the top card to 0. And again, notice right here below we see that abstract protected void set deck that both ordinary deck and Pinochle deck provide a definition for to basically construct their deck of cards according to the type of deck they are. Step again. We've built our deck, and now we call the set deck for Pinochle deck. The code is very similar. We have the ival initially set to 0, the suits initially set to clubs. These will be overridden. And then we loop through the entire set of cards. Now for this deck, we don't have to loop through all 48 cards because we have 2 copies of each card. So this loop takes advantage of that and loops 24 times from 0 through 23, building 2 cards each time. So let's take a look at that. Remember, the Pinochle deck only has a 9, 10, Jack, Queen, King, or Ace. So because there are 6 different cards, we are modding with 6, but then we add 9 to that returned value so that our range of values is 9 through 14. So our first card will have a value of 9. Recall I was 0, which when we mod with 6 is 0. Add 9, we get a 9. Our switch, because we have 24 cards, our first 6 cards, we're making the diamonds. So our first card will be the 9 of diamonds. Sure enough, here we are. We're going to construct the 9 of diamonds. That will be card sub 0. And then card 24 will also be set to the 9 of diamonds. That's our twin card in our Pinochle deck. Let's see that just one time. We'll step in here. All right, this takes us to the card constructor, validating the value and the suit. Well, just the value. The suit has to be validated because it's an enumerated type. And we're finished that card, then we build the next card. Let's step over that. And then we proceed to build the 10 of diamonds. Create 2 of those cards, then the Jack of diamonds, the Queen of diamonds, etc. Okay, let's step out of this. We're back at the end of our Pinochle deck constructor that invoked the deck constructor and then built the deck using the set deck method. So it's abstract in the deck class, and then it's an overridden method here in Pinochle and ordinary deck. Let's just look at the header of this method for a second, just to remember and notice and point out that it has to exactly match what was called out in the deck class. It's protected, it's void, it's named setDeck, and it has no input parameters. So that header has to exactly match what we saw in superclass deck, and ordinary deck will have that exact same header as well. Let's step out of here. We're back at our driver file. Let's step over these things and get to the polymorphism. Here we construct those 3 MyDeck objects. Now recall, there is no way for us to declare a deck object. We cannot instantiate an object of an abstract class. And this makes sense. There are parts of deck, such as abstract set deck, that don't exist. So we would not be able to create a deck object, as it wouldn't be able to set a deck for itself. Here's the assignment of my deck sub 0 to the ordinary deck, my deck sub 1 to the Pinochle deck, my deck sub 2 to a new Pinochle deck. Now that's kind of an anonymous deck, right? It doesn't even have its own name. The only name for this now is my deck's sub 2. Here's our for each loop. Now deck D will be set to the first deck, which is an ordinary deck. We shuffle that deck. Let's just run the cursor and see the output. So here's our output from running the code. There was our original ordinary deck and Pinochle deck. Then after assigning the my deck references to ordinary deck, Pinochle deck, and then the new Pinochle deck, and shuffling and displaying the cards, you see the ordinary deck all shuffled, the Pinochle deck all shuffled, and the second Pinochle deck all shuffled. What does this buy us? Well, for one thing, notice by pushing most of the common data into the super deck, the shuffle, the deal a card, the two string, we don't need to repeat those methods in all the derived classes. We can use that code by inheriting it and just allowing our subclasses to go ahead and call those methods. When we know we need to do something but do it differently for the subclasses, we create an abstract method, such as setDeck. The setDeck is responsible for setting up the deck of cards. For the ordinary deck, we needed to do that for 52 unique cards. And for the Pinochle deck, we needed to do that for 48 cards. That would be 24 twin cards, if you will. So because we need to do it, but do it differently for the subclasses, we will be overriding this abstract method setDeck in the child classes. Likewise, reporting on the type of deck, each of the derived classes will override getType and report themselves as either ordinary or Pinochle. An important thing to keep in mind is the constructors are not inherited. However, they will be invoked. So when we created the ordinary deck, it invoked the deck constructor, instantiate the deck, and set the top card to 0. We define those as protected members so that our child classes can easily use and access them. One last look at our Pinochle deck, that extends deck. The constructor invoked the deck constructor and then called the setDeck to build the cards. Happy coding!